in the previous videos, we discussed the limit concept we discussed, and also we discussed how to calculate the limit value, that is if x tends to any point, say for example a, in the given limit, in the given function, if we substitute that x tends to a value, then after substituting that we are getting some value. So that method we can call it as direct method, evaluating the limits by using the direct method. So what is direct method means? Direct method means what? Direct method means, in the previous class whatever we discussed in the questions, that all questions are based on the direct method. Why direct method means, my dear students, you can observe in the previous class all the questions directly we are substituting the value x tends to whatever given to you in the question, that value we are substituting. After substituting that value we get some constant value, some real number we are getting, so that we can call it as a direct method. Why we are calling direct method, that I explained. So in some situations what happens, my dear students, for example, first consider the one example here. It is evaluate limit as x tends to 2, and the given function is limit of x square minus 3x plus 2 divided by x minus 2 as x tends to 2. In this given function, my dear students, if you solve the questions whatever we discussed in the earlier classes, if you apply that method, so according to my previous method, what should we do? I should substitute the 2 value, x tends to 2 value, that is we should substitute in the given function whatever they given to you, x tends to value, whatever they given to you or point, that point we should substitute. I mean x tends to 2 is there, so what should we do? We should substitute x value as 2 in the given function. So let us check, my dear students. If I substitute means what happens here? It is, so here it is, that will becomes limit as, here it is, directly I will substitute x value as 2, so that will become 2 square minus 3 into 2 plus 2 whole divided by 2 minus 2. Wherever we have the x, there I am substituting x value as 2, my dear students. So what happens here is, this will give you 2 to the 4 minus 6 plus 2 whole divided by 2 minus 2 is 0. 2 plus 4 is 6 minus 6. This is also 0 and divided by 0. So it is nothing but 0 by 0 form. So what is 0 by 0 form, my dear students? 0 by 0 is indeterminate form. That also I told you in the last class. What are indeterminate forms? That all I explained. Is it? So 0 by 0 is indeterminate form. So what is this one? This is indeterminate form we can call. We cannot determine value. So therefore this is indeterminate form. So my dear students, while solving the limit value of the function at the given point x tends to, here in this case situation they given to you as 2. In some cases what happens, if you substitute that value, whatever x tends to value is there, if you substitute means you will get indeterminate form. In such situations, to calculate the limit value, we have various methods we have, my dear students. In that, the first one is, here it is, not first one, so many methods are there. So next we will discuss evaluation of limits using factorization. So evaluation of the limit. So what I told, my dear students, while calculating the limit value, if we substitute x tends to value, then in such a situation, if you will get the indeterminate form, if you are getting means, in such cases we will check whether we can factorize the given function or not. Clear? So first what we will do, my dear students, ಯಾವುದೇ ಒಂದು ನಮಗೆ ಲಿಮಿಟ್ ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ರೆ ನಾವು ಏನು ಮಾಡಬೇಕು, ಫಸ್ಟ್ ನಾವೇನು ಮಾಡ್ತೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ x ಟೆನ್ಸ್ ಟು ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೇವೆ. ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಾಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಸಿಕ್ಕರೆ ಅವಾಗ ಏನಂತ ಕರಿತೇವೆ, ಇವ್ಯಾಲ್ಯೂಯೇಷನ್ ಆಫ್ ದ ಲಿಮಿಟ್ ಬೈ ಯೂಸಿಂಗ್ ಡೈರೆಕ್ಟ್ ಮೆಥಡ್. But in some situations what happens, as I discussed in this particular example, if you substitute that x tends to value, then after substituting that you may get the indeterminate form. If you get the indeterminate form means in that case we have so many methods, that is depending upon the given question. if the given question is factorizable, it means if we factorize means then we can simplify. If it is factorized, then we after substituting first we will factorize and then we will substitute this x tends to 2 value. After that, if you are getting some number means that is the required limit value. In some situations what happens, trigonometric functions will be there, sin x by x, tan x by x, like that also there. In that situations how to calculate, we have method that we'll discuss later. As of now, if you have any problem like this means what, if you substitute that x tends to value, then if you are getting the indeterminate form means then we will factorize first. Is it possible to factorize? By observing only you can understand. We can factorize this one. Clear? So in such situations, how to calculate further? To discuss that one, first we will discuss generally, that is evaluation of limits using factorization. So how to evaluate if the here it is given question after substituting the x tends to point value, if we substitute means if we are getting the indeterminate form, in such cases we are going to apply this evaluation of limits using factorization. So when should we apply this one? Let's see. Given limit of f of x divided by g of x as x tends to any general point, x tends to a here I am taking, where f of x and g of x are polynomial functions. When x equals to a, if you substitute that x tends to a is here, if you substitute x is equals to a in the given function, if it takes 0 by 0 form, like this situation, if you take 0 by 0 form, in that case what we will do, my dear students? Then in such cases, then factorize f of x and g of x. It means numerator terms and denominator we will factorize, and then we will cancel the common terms in the numerator and denominator. If any common terms there means we should cancel, and after that we will evaluate the function as x tends to a. X tends to a means what? X tends to a means we will substitute x values. That is nothing but direct method. We will substitute x value. Then we will get the required answer. Am I clear? I hope you understood. So we'll solve this question based on this one, my dear students. So see here, what I will do here is, or just I check what is that one. Rewrite. I'll rewrite here. See here. So this is the example for this one, my dear students. Evaluation of the, here it is evaluation of limit by factorization method. So I'll solve here it is, when x is equals to 2, if you substitute x value as 2 here, so what happening here it is, 2 whole square minus 3 into 2 plus 2 whole divided by 2 minus 2. We are getting 0 by 0. I hope you understood. So therefore we got, already I told I simplified this one. Is it? This value is 0 by 0 form. So therefore I write in words only. Therefore here we got the 0 by 0 form. Therefore we will factorize here this method. So what we will write, my dear students? Therefore limit as x tends to 2. Here it is x square minus 3x plus 2 whole divided by x minus 2. So this one we will factorize, my dear students. So this implies limit as x tends to 2, x square minus 3x plus 2. So factorize this one, factorization. How to factorize this one? X square minus 3x plus 2 equals to 0. We will factorize this one, my dear students. So how to factorize means multiply this term and this term. That is 2, here it is 2 into, what we will do here it is, I will solve here this. So first multiply these two, my dear students. So 2x square and middle term is minus 3x. We should choose the two terms in such a way that if we multiply these two means we should get this one. If we add or substitute, if we subtract means we should get minus 3x. Like this we should factorize. This already you learned in your earlier classes, factorization method. Clear? So here it is, if you factorize means, my dear students, what happens here it is, 2 ones, here it is 2x into x minus 2 minus x, minus 2x minus x is minus 3x minus minus plus 2x into x is 2x square. Clear? So this we can write it as x square minus 3x we can write it as minus 2x minus x plus 2 equals to 0. In place of minus 3x I wrote minus 2x and minus x. So further simplify this one, my dear students. So if you simplify this one means here it is, now take the common, here it is x minus 2, and now here it is minus 1 we will take, minus x minus minus plus 2 is equals to 0, minus minus plus 2. Now take the common, x minus 2 into x minus 1 equals to 0. It means if you factorize this one means we can write it as x minus 2. This term numerator I am factorizing, x minus 1 whole divided by x minus 2. So my dear students, this way we can factorize. So this implies, now this x minus 2, this x minus 2 got cancels. So don't confuse with equals to 0. Leave that one. Only write this much. Factorization only I am doing. Clear? So x minus 2 got cancels. What is ultimately you are getting? X tends to 2, x minus 1. Now directly substitute this x value. X is equals to 2. If you substitute means 2 minus 1. 2 minus 1 is 1. So therefore the value of this function limit as x tends to 2 is equals to 1. I hope you understood my questions. The same procedure whatever I explained that I did here this. Understood? So please write down this question. Please pause the video to note it down, and we'll discuss the next type, how to evaluate the limits. Clear? So please pause the video to note it down. Yes. Now my dear students, previously we discussed evaluation of the limit by using factorization. Now I wrote the next one heading, that is evaluation of the limits using limit of x to the power n minus a to the power n whole divided by x minus a as x tends to a. If we have this condition, if the given question is in this form, in that case directly we can write the limit of this value is n into a to the power n minus 1. Clear? So please remember this result. This is very very important. Usually they will ask for 5 mark question derivation, they will ask, but now exams are cancelled, so just we should use this result here. So clear? So no need to revise or practice that derivation. Simply we will use this result, my dear students. Clear? So please remember this result. So now when we should use, my dear students, when we should use means if the given question is like this. I took one example here. It is limit of here it is limit as x to the power 4 minus 16 whole divided by x minus 2 as x tends to 2. If the given question is like this, I mean if any given question, if I am able to write in this form means directly we can write the limit value like this, because each time we cannot calculate, each time we cannot derive this derivation here. This means whatever we have the derivation that we cannot derive each time. So directly what we will do, we will apply this result. So please therefore remember this result, my dear students. Clear? So now first of all my job is to express this in this form. Clear? So here it is given. What is the given here? It is the given question is limit of x to the power 4 minus 16 whole divided by x minus 2 as x tends to 2. Now I'll rewrite this one. This is also implies x to the power 4 16 I may write, my distance 2 to the power 4 whole divided by x minus 2 as x tends to 2. Remember this. I can write the given question x to the power 4 as it is, x to the power 4 as it is. 16 I can write 2 to the power 4. You may ask, why sir you are writing 2 to the power 4? We can write any other number to the power 4, any other number we can write. Clear? But I am writing 2 to the power 4 only I am writing. Instead of this I can write 4 to the power square. 4 whole square also I can write. But why I am writing particularly 2 to the power 4? I am writing particularly 2 to the power 4 because this numerator and denominator should be same. I mean here x to the power n minus a to the power n whole divided by x, and here it is a. Both should be same. Therefore x here also I should get x. Here 16 is there, 2 to the power 4. Here also 2 is there, here also 2 is there. To make these values same, numerator and denominator values same, I am making the same here, this denominator and numerator, to apply this result. Clear? So therefore I wrote like this, and now my dear students, this value is equals to, I am applying this formula. What is the formula? n into, what is the n here? It is in place of this one, n is 4. So n into a, what is the a value? Here it is a value. Compare this and this. So 2 a n into a to the power n minus 1. N is 4. 4 minus 1. So this implies, here it is 4 into 2 to the power 4 minus 1 is 3. Clear? So 2 to the power 3. 2 to the power 3 means 3 times. So we should multiply 2 3 times. 2 to the 4, 4 to the 8. So this is 4 into 8. So 8 4 the 32. So this is the answer for the given limit here. It is clear. So like this we will solve, my dear students. So one by one we are discussing. So what is the, that is everything is to calculate limit. Everything is depending upon the given question. If the question is like this in this form, x to the power n minus a to the power n whole x minus a, in that case we will solve using this result. Clear? If the given question is if it is factorizable, easily we can factorize, means in that case we will apply evaluation of limits by using factorization. If directly whatever extends to particular value is there, if we substitute in the given limit, if we are getting some value and that value should be in the domain of the given function, if particularly it means generally if you are getting some constant or some values, means that method we can call it as a, what we can call that method, we can call it as a, here it is first one I told, what method that one, I think that is direct method. Clear? So we are discussing to calculate limit value. Here it is what we are discussing, evaluation of the limit by direct method. That first I discussed, I mean in the previous class I discussed. In today's class I am discussing evaluation of the limit by using this result and evaluation of the limit by using factorization. Clear? Some more like these results are there, my dear friends, that I am going to discuss later. But as of now, please pause the video, note down this one, then I will move to the next one. So pause the video and write it down. Yes, my dear students, the next type is, this is very important, my dear students. So again, if how to evaluate the limits, if the evaluation of the limits using, if in the given question if we have like this sin x by x or tan x by x, like this something if we have, means in such situations we can use these results, my dear students. So what is that one? So first one is limit of sin x by x as x tends to 0, this value is equals to 1. Similarly, another one is limit of tan x by x as x tends to 0 is equals to 1. These two results are very important, my dear students. Please keep in your mind. Clear? These two results are very important. Please remember this one. We are also using these two results in the second year also, and next some topics also we are going to use this one. So very important result these two. So please remember this one, my dear students. Clear? So here what we are doing, my dear students, we will discuss the question here. In this question we are going to use that result. So see here it is, my dear students. Evaluate limit of sin ax by sin bx, limit as here it is as x tends to 0. Limit of sin ax divided by sin bx as x tends to 0. So how to solve this one? To calculate limit of this given function, my dear students, please remember what is the result we have? The result we have is limit of sin x by x as x tends to 0. It means sin of this angle and the denominator should be same and x tends to 0. In that case the value is equals to 1. So therefore to convert this we have only sin ax, my dear students. In the denominator also if I have ax, then I can apply that result. Clear? So for that reason what I will do, to this one I will write limit as x tends to 0, sin of ax to the numerator I divide ax and I multiply ax. This x got cancels and you will get sin x. Clear? So there is no any harm to the given function. So in the denominator also what I will do, my dear students, sin of bx whole divided by bx into bx. Again I am multiplying and dividing with bx. Bx got cancels, again you will get sin bx. Again to the function there is no any harm. Clear? We can multiply and divide to the any number, any value. With that is the basic rule we have that already we studied in the high school level. Is it? Here. So now, my dear students, I will apply the limit here. So limit as x tends to 0. Here it is. We can write sine of ax whole divided by ax into limit of x tends to 0 of ax whole divided by limit. I am taking numerator and denominator. Here also limit as x tends to 0 sine of bx whole divided by bx into limit of that we discussed. If we have a product of two functions, we can write like this. That all we discussed in the algebra of the limits. Clear? We can write splitting. We can write. So limit as x tends to 0 into bx. Just I am applying limit to all numerator and denominator. In the numerator we have this is one part, this is another one part. Limit of this part into limit of this part. Again in the denominator also limit of this part into limit of this part. Clear? And now my dear students, this result is, I mean, if you apply the result here, it is what is the result we have? So limit of sine of ax divided by x. It means sine x by x tends to that value is 1. So therefore this value I can write it as 1, and even this value is also I can write it as 1, my dear students. Clear? So that is equals to 1 into limit as x tends to 0 ax whole divided by limit as x tends to 0 of bx. And my dear students, please remember here it is, here also x is there, here also x is there. So x got cancels, we will get only a by b. Here it is, before substituting x tends to 0 value, what I do my dear students? Here it is ax and bx. So we will cancel the term, x got cancels, and next only we will get a by b. So this is what our required answer. Like this we can solve the limit concept. These are the very important results, my dear students. Please remember this one, and please pause the video to note it down. If you have any doubts, you can comment me. I will reply for that. Clear? We'll continue in the next video. Thank you.